Hi, welcome to Computer Science Explained. In this video, we will talk about variables in programming. Variables in programming are different from variables in mathematics. In mathematics, a variable represents an unknown value. For example, in this equation, 2 times x plus 1 equals 7, variable x represents an unknown value that can be substituted instead of x to obtain true equality. Let's find out this value. As we can see, if and only if x equals 3, our equation is true. In programming, a variable is a named storage location in computer memory. It holds data that can be changed during the execution of a program. You can think of a variable as a box. We can put some value inside this box. Let's, for example, put 5 inside our box. We can look inside this box and see what value is stored inside our box. We can put another value inside the box. In this case, the old value will disappear, and only the new value will be stored. Let's, for example, put 9. Variable consists of a certain number of consecutive bits in random access memory. Variable unites all these bits in the whole system. Random access memory is the type of memory that can store information only when an electric current is on. Each variable must have its own name, which permits distinguishing different variables when writing programming code. A programmer chooses the name of a variable. Also, a programmer chooses a type of a variable. The type of variable determines what kind of values can be stored in a variable. Also, a type of variable determines the number of bits that constitute this variable. The main types of variables are integer, floating point, and character. Integer type variables can store positive and negative integer numbers. For example, 6 or -4. Floating point type variables can store positive and negative numbers with fractions. For example, 2.5 or -0.75. Character type variables can store letters, for example, P or V. If we use an incorrect type of variable, mistakes can occur. For example, if we try to set value 2.9 to an integer variable, value 2 will be stored, because the fractional part will be discarded. Let's see some examples in C++ programming language. Examples in C and Java are almost the same. First, we write the type of variable. Let's take int. Then, after space, we write the name of the variable. Let's take x. This is the definition of the variable. During the definition of the variable, operating system of a computer allocates in random access memory required number of consecutive bits. Each variable has its address in random access memory. All bits in random access memory are enumerated. The address of a variable is the serial number of the first bit of the variable starting from the beginning of random access memory. A programmer cannot affect the address of a variable. Only the computer's operating system decides which part of memory will occupy the variable. Let's create one more variable. We write int y. The operating system of a computer creates another variable. Please pay attention that we create variable y after variable x in our program, but the operating system of the computer can create this variable before or after in random access memory. In other words, the address of variable y can be less or greater than the address of variable x. We can find out the address of a variable with an ampersand symbol before the name of a variable. This symbol looks like AND. This code prints addresses of variables x and y. The result can look like this. 0x means hexadecimal number system. The main idea about random access memory is that we can access any variable almost instantly. Time of access does not depend on address, or in other words, how far from the beginning of the memory our variable is. So, access time is constant. We can jump to any variable almost in no time. This is very important. If we have to go to a variable passing all bits starting from the beginning, access time will be linear, and all programs will work very slowly. Fortunately, we have fast access to any part of memory. That is why this memory is called random access memory. Now we have two variables in memory. But what values do they have now? Both variables contain garbage. In other words, they can contain any value, because we did not assign certain values for both variables. Any bit in random access memory can be in one of two different states, 1 or 0. When the operating system created variables, it took bits that already had some combination of zeros and ones, which were left from previous owners. Previous owners can be variables from programs that worked before but already finished work and freed memory. Of course, the operating system doesn't change these bits until we tell what value we want to set. The only exception is when we define a global scope variable. The operating system sets 0 automatically if we didn't set some value to the variable. We need to use the assignment operator to set some value to a variable. It looks like the equality symbol in mathematics, but works differently. It takes value from the right operand and assigns it to the left operand. Of course, on the right shall be something that has value, for example, a variable or number. And on the left shall be a variable that can store value. Let's assign value 7 to variable x. The first assignment is called initialization. It is good practice to initialize during definition. Let's define and initialize with value 5 the new variable z. Now let's initialize variable y with value 9. We can assign the value of variable x to variable z. Now the value of x is 7, the value of y is 9, and the value of z is 7. It is good practice to choose names of variables such that these names reflect meaning. For example, in a database program, it is good to use names like name, age, salary, etc. Names like x, y, and z can be perfectly used for 3D space coordinates. Thanks for watching. See you next time.